Hello viewers, in today's lecture we are going to take up the concept of eccentricity of an ellipse. So eccentricity is an important property of any conic section, right? So here we have a rough sketch of an ellipse whose major axis lies in x-axis and the minor axis lies in y-axis, right? Suppose these are the two foci of the ellipse f1 and f2, and O is called the center. O is called the center. Now f1 and f2 are the two foci of this ellipse, and f1 has coordinates c comma 0, f2 has coordinates minus c comma 0, and here we have a point A and here we have a point B, right? This is C and this is D. So AB is called the major axis and CD is called the minor axis, right? Okay, and O is the center. So here the coordinates of A are A comma 0, the coordinates of B are minus A comma 0, and the coordinates of C are 0 comma B, and the coordinates of D are 0 comma minus B, right? And suppose P is any point on the ellipse, and we know that the length of the major axis is 2a and the length of the minor axis is 2b, and the standard equation of ellipse is given by x square over a square plus y square over b square equal to 1, right? Okay, so now we have to define the eccentricity of an ellipse. So the definition of the eccentricity of an ellipse goes like this: the ratio of the distance from the center to the foci, that is this distance, right? This distance, which is C, and the distance from the center to the any vertices, right? So here A and B are called the vertices of the ellipse. So this distance is A, right? So the eccentricity is denoted by E, and it is defined as the ratio of C and A. So C is the distance of the center from the foci, and the A is the distance of the vertex A from the center. So we can write C is equal to the product of A and E. Now the relation between A, B and C is given by A square minus B square equal to C square. So C can be written as square root of A square minus B square. So now substituting the value of C from this equation to equation number 1, so we get E is equal to square root of A square minus B square divided by A. Now this can further be written as square root of A square minus B square over A square, right? Taking this A under the square root sign. So now this can further be simplified as 1 minus B square over A square. So the expression for the eccentricity of the ellipse is given by square root of 1 minus B square over A square, right? So we see that from this equation or from this equation we conclude that see the value of a is greater than c, so therefore the ratio of c and a is less than 1, and c divided by a is given by e, so e is less than 1. So always remember the eccentricity of an ellipse is less than 1. Now let us consider some conditions, and the first condition is what happens when a is equal to b. So when a is equal to b, from this equation we see that c square is equal to a square minus a square, because a is equal to b, so c square is equal to 0, so c becomes 0. So in that case the eccentricity becomes 0 divided by a, and e is equal to 0. So the eccentricity is 0 when a is equal to b, so it means in that case the ellipse reduces to a circle, right? So the ellipse reduces to a circle when e is equal to 0, right? Okay, so now let us consider one more situation. So when we know that the value of a is greater than c. Now when the value of c, it approaches to a, right? It means when c is almost equal to a, then the eccentricity becomes c divided by c, and it is almost equal to 1, right? So in that case we see that, or we can conclude that e is very close to 1, and in that case the ellipse has high degree of ovalness, right? Ovalness, or in other words we can say that when e approaches to 1, that is when c approaches to a, then the ellipse is said to have a high flatness, right? A high flatness. Now let us find out the eccentricity of this ellipse. So the equation of the ellipse is x square over 25 plus y square over 16 equal to 1. Now if we compare this equation with the standard equation, then we see that a square is equal to 25 and b square is equal to 16, right? So the value of a is 5 and the value of b is 4. Now we can apply this formula, right? So eccentricity is given by square root of 1 minus b square over a square. Now if we substitute the values of b square and a square in this equation, then we get e is equal to square root of 1 minus 16 divided by 25, and this can be written as 25 minus square root of 25 minus 16 divided by 25, and this is 9 over 25, which can be written as 3 over 5. So the eccentricity is given by 3 over 5, which is 0.6, and this 0.6 is obviously less than 1, right? So we see that the eccentricity of an ellipse is always less than 1, and when the eccentricity approaches to 1 or very close to 1, then we say that the ellipse has a high degree of ovalness, right, or high degree of flatness. And when A is equal to B, it means the length of major axis and minor axis are equal. Then the value of C is 0 and the eccentricity reduces to 0, and in that case ellipse reduces to a circle, right?